So I think, yeah, it's time to get started. Most of the people who have been waiting maybe have joined the session. I think we have all set from our side. I believe, yeah, I think Srinidhi, we are all good to go, I believe, from our side. Okay, great. Looks like we are also live on YouTube to get us started with this session. So I think, yeah, it's time. Perfect. Good. So give us a second. My co-host. Okay. All right. So by the way, yeah, let's get started. Hey, good evening, everyone. I'm Suraj. I'm the co-founder and course director at Decibels Lab. Good to connect with all of you today for the discussions on battery management systems. As a part of today's discussions, we will be interacting on the topic of battery management system and focusing to functionality with the live demonstrations. So, and a lot of people here, I see that you are interested to become an algorithm engineer. Maybe you want to design a BMS, or you want to do some other stuff in place. But at the end of the day, you have to know the fundamental functionality to define, anything as an algorithm, or even to design a BMS as well. Today, the session will cover an application perspective. It means, let's say the BMS is already there. There is an already algorithm which is there inside the BMS. And then let's say you have a graphical user interface to interact and make some modifications for that BMS. So then how does it actually work, right? And what are the requirements are there, and how do you customize component configurations so that you will be able to get an output which is for the requirements of the battery pack or a vehicle applications and things like that. We may not focus on designing a BMS in this session. We will only focus on making the BMS to function so that it will be able to get an idea that what all the list of functionalities the sessions will have, right? So with that, to make this happen, so we have Srinidhi, who is our EV R&D engineer at Decibels Lab, who's been delivering a lot of sessions on the areas of vehicle testing and also for the areas of anything that comes in the hardware interfacing and stuff like that with the electric vehicles. So over to you, Srinidhi, to get started with the session. And thanks everyone for joining in, and enjoy the session ahead. Thank you.
Thank you, sir. Good evening to all. So today's session is on battery management system functionality. We look on basically what all functions BMS does. So the topics which we will be covering today are on the hardware overview. I wouldn't go in depth on the embedded or the board level, just the BMS hardware overview, and basically how do we integrate it to the battery pack. How is the connection done with the battery pack? How are the software interface of the BMS for configuring it for the smart BMS especially. We look at how do we configure the basic parameters based on cell data sheet, and what all basic protection parameters are there available. And we look at some examples also on how balancing happens while charging, while discharging. And we'll also touch upon live demonstration on BMS functionality, few of the functionalities when it's connected to an electric vehicle. We'll just move ahead. So before we begin on the hardware overview, I will just give a glance on why do we need a BMS. So basically, BMS or a lithium ion cells, usually a lithium ion battery packs, cannot be handled without a BMS. It's not at all, what do I say? It's not in a stable condition, even if you're discharging or even if you are charging or discharging, or even if you have just kept it as a storage, right? It's very highly unstable. So due to this instability, the only a device which would control this battery packs, battery management system, that's BMS, right? So usually
Hello.
as a, yeah, hello,
Hello.
yeah, who is this? Guys, can you just mute yourself? You can ask your doubts at the end of the session, okay? So that I'll just go with the flow. Yeah. So basically, the major role is to ensure safety of the battery pack and also surrounding inside the battery pack and also the surrounding of it. And other parameters like battery pack and battery capacity estimation, that's SOC, right? State of charge. Similar ones that which you see on your mobile phones. What is the remaining SOC percent? 80%, 60%. So to calculate it accurately and give the user the data so that he or she will be able to plan maybe the ride if it's related to electric vehicles, uh, where should be the destination or what should be the traveling range that day based on the SOC. And battery health estimation is another important role, SOH estimation. So why this parameter is important? Because it's not just giving you a current status of SOC will matter. It's also very important. A role of a BMS is to monitor the battery health for a prolonged period after a prolonged usage, right? If you buy a battery pack, or I'll just give you an example of if you buy a new laptop or a gaming laptop, it would give you a time of 2 hours after you charge, right? Full charge, 2 to 3 hours. So if you have observed after 1 or 2 years, the even if you charge it full, the availability of time is around 1.5 hours or 1 hour, right? It decreases along the usage. So we don't know how much accurately you will be able to use the battery pack if the SOH is not estimated. If I give an example of electric vehicle, similarly at the vehicle's new condition, according to company claimed you might get around some 300 kilometers. So, but after prolonged usage, if the SOH is not calculated properly and you are planning your ride, it is again related to SOC. It might be showing you 100% charge, but you don't know whether again will it be able to go 300 kilometers only. It might be less due to the aging, due to the continuous usage of the battery pack and all, right? Then battery failure prediction and prevention. Yes, the BMS does both the roles, prediction also and prevention also. And all the as I said already, act as a safety device. Then also majorly to monitor while discharging and charging, uh, not allowing the battery pack to overcharge, not allowing the battery pack to over discharge. Like this, a lot of parameters has to be monitored and controlled, right? And it's not only about the complete battery pack level, it's also about the cell level to make sure each cell present in the series or parallel combinations are monitored and well balanced, even while you're charging or discharging, or even when it's in just a storage mode, right? And also diagnostics to, as I said, if any balancing is required, right? And a few other parameters are like it can communicate. So if you have a lot of modules present, for example, it's a car battery pack, car overall battery pack, it will have a lot of modules, right? Because it's around 300 volts, 320 volts, you would have something like 48 volts modules which are connected. So each one of the battery pack will have its own BMS. Again, that will be controlled by a master BMS. So these will be slave BMS. The one which controls will be master BMS, right? And you can also log the data. So if companies or if your product have been launched in the market, right? It's a newly launched product, or even as a consumer, you want to log that, know the consumption of current based on your driving, right? The way you ride, how the current was consumed, or how the current was discharged, and how the energy was consumed by the battery pack. So even as a consumer level, also for the manufacturer level, it's very helpful, right? So first we'll start with the battery BMS integration with the battery pack, right? How do we connect any whether it's a smart BMS? So on the left hand side, which you see is a smart BMS. On the right hand side are the non-configurable BMSs, right? You can call it as dumb BMS also. So once these BMS are configured uh, from the manufacturer side, you won't be able to monitor it, nor you will to configure it, right? So but that's not the scene in the when it comes to smart BMS. So where you will have a communication port here, right? They have an option for to communicate via Bluetooth, or also via RS485, and then you just convert it to USB. So you can just communicate with this BMS and get to know complete data of this battery pack. What is the current status? How is the battery behaving? Or if you can also log the data and get to know how the battery had behaved for certain loads and all. So complete configurations can be all the basic safety parameters can be configured here, right? So this is the left hand side, you have smart BMS, and the right hand side you have uh, non-configurable BMS. First, we'll go with the wiring connection. It's very simple. I will just explain you on how the connections are made. I wouldn't go in depth of how these PCB boards are made, right? So it's only about the integration part. So first part is that this is how the BMS look like on a schematics level, a basic schematics level. So you have a B minus port. That's nothing but battery negative. B minus stands for battery negative, which will be something like this. Yeah, this thick black wire you see, that's a B. Sorry, this thick blue wire you're seeing, right? That's a B minus port, which is going to negative. And you'll have a C minus port, which is nothing but a charge negative, or you can also call it as discharge negative. So that's a common port. It can be used for, it will be used for charging also, for even discharge. Then you have communication ports, as I mentioned. It might be RS Bluetooth communication or RS485, right? Here you can see this is a communication box. Sorry. So you can connect it via communication box, and at the end you can get the USB port, so that you can connect your laptops and configure all this. Or via Bluetooth, you can connect to the application and configure. Then some of the smart BMS on off switch uh, based on the application if needed. Then you have NTC sensors. That's nothing but thermal sensors. Sorry, this part is visible, right? Okay, wait. I'll just show you another picture. Yeah, this part, right? These are NTC thermistors. It can be up to 8 or 9 based on the again the BMS and application. Right now you are seeing the one BMS. Usually how it would be like, you have external thermistor which will be connected, which will be placed inside these battery packs. You see the gaps between these spaces, they will be placed. Um, Also, there'll be a sensor on the board level. So this is your BMS board, right? So there'll be sensor on this board level also. So when you connect it with the software, it will be showing the board level temperature, also the battery pack level, right? Then you have a pinch for series connection. So before, when I'm talking about series connection, BMS has a basically two configuration. I guess it's visible here on this part, not so clear, right? So the two configuration are, yeah, it's here. Series connection and the discharge current. So these are only two basic parameters or important parameters you require. Based on this, you select the BMS. So first one is series. That's nothing but indirectly connected to voltage, right? So if I have 48-volt battery pack, so I would be having a 13S series, right? So I would have to connect a 13S series only. Anything above 13S is fine. You can use also 14S. It's just that you can leave a single wire as an empty series, and make sure that the last what do I say, positive wire to be connected at the end. So the circuit gets completed and can be used. But yeah, lesser than that number, we can't go with it, right? So you have series connection and discharge. Again, discharge current based on your battery pack, right? So if it is a, for example, this is a 30Ah battery pack. 30Ah means at nominal it will be able to give you 30 amps of current. Now, if those cells are, let us assume it's the cells are, what do I say, 1C cell, 1C rated cells, right? So 30 amps is the nominal capacity, or it is the max it can give from the battery pack. So you would choose the BMS based on that. So you would choose a BMS such as 13S, 30 amps discharge current, right? For example, let us take your nominal voltage, current is 30 amps only, but the cells which are used at 3C rate, which means that it can perform 3 times of it for the peak condition. That means it can give up to 90 amp for certain time duration at its peak condition. So you would have to choose a BMS which is suitable for such configuration only. It doesn't matter on what's the nominal current which you're using, right? I mean, if the application is such a way that you're going to use the 90 amps, so you'll have to go with it. And that means that BMS will be able to protect you till the discharge current, which is mentioned over here. Above that, it won't be able to. I mean, it won't be able to perform anywhere, and you won't be able to use it, right? That's the max current, discharge current it can give. Right? Let's go back to the connection. So always the BMS controls on the negative part, negative end of the battery, right? That's what you can see here. Also, this is a battery pack. So all the BMS connections or the controlling is done on the negative end, not on the positive end. Positive end is always taken directly from the battery pack. I'll just show you again here. You could see this is the positive end of the battery pack, and this is the negative end of the battery pack. You can see the connection is done only to the negative end. Positive end is directly taken out to the connector, right? Which will be used for reload. So that it goes like you connect first to the BMS goes to the negative terminal of the first terminal. So this is the negative terminal. You can see the BMS is going to first negative terminal. Then if you have a 13S series, I'm just giving an example. If you have 13S series BMS, you would have around 14 wires, right? So in this, the one which I'm showing you has 14 wires. So 12 are white wires, and one is black and one is red. So it just indicates that first one is the negative and the last one is positive. In between is for the series connection. So you connect the thick wire first, then you start with the first B0, right? Yeah, that's B0. B0 is the cell back negative. So which you connect it to the negative terminal. If you could observe, there's a thin wire just beside the blue wire that's going to the negative terminal. So you start with this thick wire, then you go with the B0, that's black negative. Then further it goes on like B1, B2, B3, B4 up to B13, right? If it's a 13 series, it's up to B13. So these are the positive sense wire for each cell. So it goes like negative, then first negative thin wire, then you go with the other positive end parts. I mean, for each series connection. So that is how you could measure if these wires, when these wires are connected, then only you will be able to get in the software interface that, okay, series 1 has so and so voltage, series 2 has so and so voltage. That is how you will be able to monitor if all the series are in balanced state or not, right? Then once this series connection is done, as I mentioned, you just take the positive part directly from the battery pack, and you collect the charge negative and discharge negative from the BMS, and you have the two ends which will be directly connected to the load. You have the positive end and you have the negative end here, right? So what are the observations which has to be observed while integration? Right. I'll just have some few points on that. You could see there are bold and thick wires used for the discharge current or at the end of the discharge, right? You have here bold and thick wire, you have right here bold and thick, right? Why is it? It depends on current carrying capacity. The wire has to has the capacity to flow such amount of high current. So it's basically based on the current flowing capacity, your gauge and the thickness of the wire matters. So high gauge wires are used and multi-strands are used to basically to withstand 30 amps and all, right? That's a huge amount of current which won't be able to pass via these thin wires which you are seeing here. You would have a question that, okay, why are we using thin wires here? So these wires are just to sense the what is the voltage of series. They don't discharge any current. The current is only discharged via this bold and thick wires at the end, right? That is the one observation. Another observation, you could see that at the B minus only, you have two ports available. Even here, there's another hole present here, right? A hole for the port to connect another wire. Or here also you can see there are two wires connected. Why is it? Let us assume that you have a 60 amp BMS. So 60 amps is if you want to select a wire for a 60 which would allow for 60 amps would be very thick. So in order, what I will do, I'll just use two wires of 30 amps, which will just add up. So I'm just dividing the current into two, so that the thickness won't be more, and it's more in a safer way, right? Similarly, I have two ports for. Usually, we have two ports for at the charge or discharge end. So one will be the for charger. So these two wires will go for the charging part. So and these two parts will go to the load. That's the motor end, the motor controller end, right? So that is how basically the connection is done. You go with the B minus, the negative parts are connected. Then you go with the positive series connection to sense all the series. Then at the end, you directly take the positive end out of the battery pack. Then the common port is taken from the BMS. Right? This is how we connect, which is seen. So these are the series, each series strips, which you can see. This is an example of a 13S BMS, which we have built at Decibels. We'll look more into visuals when we go to the live demonstration, right? So this again a better picture to show you how the integration happens, how the connections are. So let's not concentrate on what are these parts which are present here. So you have your MOSFETs, you have shunt resistors, and a lot of things are present here. Let's not go in depth for that. We'll just go on how the connection happens. So again, I'm just repeating it. B minus, you have see, it's clearly mentioned use board thick wires to connect the negative. Why? Because these are discharge or charge ends. Again, charging usually charge depends on the charger and the battery pack application. whether you are using 6 amps, the thickness will be lesser, and whether it's higher amps, the thickness will be more, right? Just make sure that you don't blindly use thick wires, because even if you use a lot of thick wire, or the length of the wire is more, the current will be wasted there again, or you won't be able to use the load properly based on the application, because it's a wastage of current directly from battery pack. So always based on the gauge calculation, according to the current flow, you have to be considered here. So this is how a connector looks for the series connection pins. You have a connectors which will go directly plugged into the BMS, and you have all the wires, which was seen here, right? So now the integration part is done. You have integrated a smart BMS to your battery pack. So now let us look at the software interface. Again, if the first question will be on your mind, which software to use? What software are you showing right now? So software interface is usually given from the BMS manufacturer side only. Whether you can take an example of Orion BMS. There are many BMS companies right today. Right? I would say some Chinese BMS or some BMS are made in such a way that they have a common software, uh, such as like a JBD tools, which can be used to configure the particular BMS. So this is how the software window looks like. Basically, it is divided into 4 parts: pack information, settings, calibration, other function. Right? You have a COM port here. So I'll just demonstrate later how do we start it and how do we connect and all. We'll just have a glance at how the software interface looks like. So as I was mentioning, these are series connection, right? These wires will go and connect to the series, and it will sense and monitor that particular series. So that is what I was. This is what I was mentioning about. You could see all the series connections voltage. So when they are connected properly, then only you're able to see the voltage values here. So you should make sure that uh, when you're connecting, it should be in order wise. So you start with B0, then B1, B2, B3. So if these are interchanged in the series connection, then you will be having a wrong information for you. For example, this was supposed to be uh, by miss you have connected in place of 3 series 10. So it will be showing you the series 10. Then you won't be actually, you'll be confused later which series has any balance issue or which has been in balance state, right? So you have to make sure that you go in the proper order. So then you have balance function here. So if the series required any balance function, automatically it will show on here. Otherwise, it's a blank. Then, as I was mentioning, usually we have 2 temperature sensors, one on board and one on battery package. It's not limited to only the 2. It can be for higher. Again, it's based on the which BMS you choose. Then you have a live status view of the battery pack, where you will be showing the remaining SOC of the battery pack. What is the pack voltage currently? What is the current at this moment? Average voltage, the maximum voltage, minimum voltage in comparative to all the series. What is the difference between the voltage in the series? Then you have cycle counts. Now, what are the cycle counts? As I was mentioning, state of health. This is related to it. So cycle counts are nothing but a one life cycle of a battery pack. One cycle of a battery pack is a complete discharge and charge. So usually battery manufacturers show you the or they mention you the life cycle of the battery pack based on the cycle. In terms of cycles, they would say you 2000 life cycle cycle counts as a complete life cycle of the battery pack, or maybe 3 years or 2000 life cycle. It's just similar to how they say for your battery. Your vehicle, right? 300 kilometers or so and so days. Similar. Then you have full charge capacity, remaining capacity, and the version which you have used, the BMS version. And you have two indicators here, which is charge FET, that's nothing but MOSFETs, charge MOSFET and discharge MOSFET. MOSFETs are nothing but in layman term called as switches, right? It's just a protection level switch, just like an MCP. If anything goes wrong, it will turn off and cut off the connection. So we have two different indicators for charge related and discharge related. And here you have a complete warning window, I would say. So if anything goes over, anything goes above the limits, all the warnings will be here. So this was the MOSFETs I was talking about. So one will control the charge part and another will control the discharge part, right? So then you have a complete BMS software in the settings level as a basic parameters, where you would set all the under voltage protection value. So on the left hand side, all the values which are the limit which you're setting. On the right hand side will be the middle part are the release values. So basically, when such limits are attained, the BMS will get into action, cut off, and it will stay in delay time for the which you have mentioned here. After certain delay, after the delay time is over, it rechecks. While recheck, it will make sure that these values are reached. If reached the release values, then it will reactivate the complete module. If not, it will stay as it will again deactivate and cut off. Right, this is the how usually BMS works. So you have other, we look into this in further in detail, what all the functions are. Then you have a balance function and charge balance function. And these are the temperature sensors which have been connected. These are the configuration of the one which you have connected here to the BMS, which has the device name and all. And usually you have a high protection. So there are two level of protection. One is basic protection, and there's a next level of protection, software level also, and also hardware level. So which will basically protect you in any inrush currents or short circuits over current which is passing over this. So there's usually two levels of protection. So all these parameters you set and you write it over the BMS. Then you can save the program. You can read the program also, and you have an option to save the data, right? If you just click on it, it will save. So when we look at the basic protections, we have here is that cell over voltage protection. What does it mean? So if every cell, and I mean these values are set only according to cell data sheet, right? It's not the ones which you want. You just can't update it based on any according to your usage. The cell data sheets are again provided from the manufacturer. You just look at all the parameters here regarding nominal capacity, nominal voltage, what is the max charge it can take up to, what is the discharge cutoff, what is the max charge current, whether it's a 1C cell to 3C cell, whether charging is 1C or 3C. Every information will be, including the storage temperature, operating temperature. Each and every information will be given on the datasheet. Based on that, you will set all these parameters, right? Under voltage, that's under a certain value. The what is the max discharge it can do, or cell can do. Then you have over temperature protection, under temperature protection, discharge over temperature, again discharge under temperature. Then you have over current protection while discharging and also while charging, right? So before we go to the demonstration part, I'll just give in a brief picture idea of what I was saying on the balancing part, right? So let us, this is the picture depicting when the BMS and battery pack is connected to a charger. So you can see there are four cells present here, or series you can also take it as. So they are in different voltage, right? They are not in balanced state. So when you on the charger, the current passes and the charge has been being placed and going into all the cells. As soon as a 4.2 volts, that's the maximum voltage which I have set, it will cut off. You can see there is a complete cut off between the charger and the battery pack. So this is kind of gateway, protector gateway, the BMS will act like. So again, it will release when you are given the release value. So I was talking about limit value and we have release value. So when the release value has been attained, it will activate or it will allow the charger to pass the current, right? So again, any of the cell attains the, what do I say, the max voltage level, it will cut off. So this is how it gets balanced, and it makes sure at the end that all the cells are balancedly charged and equally charged. It doesn't allow what do I say, a lot of current only to the certain cells. It makes sure that all the cells are equally charged. So one more example while discharging, how it controls. So you are discharging under load. The load can be battery, load can be motor, bulb, any auxiliary, anything. So when it's under load, you have set a certain discharge cutoff voltage, right? When it attains that certain voltage, it will cut off from the load. So it makes sure that this is how it makes sure BMS makes sure the battery pack is always in a safer condition according to the parameters or conditions which you've set, right? This is just an example of discharging. Uh, let's see it further. And as I mentioned, you'll be in the software part, you can also log the data, right? This is how that log data looks like. So you have date, time, pack voltage, what is the current at the status, series 1, usually represent as L1, series 1's voltage, series, up to series 30, average voltage. So all the live data information which you are seeing, everything will be present and logged here. So even if any protection status was on or off, or if the discharge MOSFET was on or off, all the temperature conditions, everything will be logged here. So now we'll look at the demonstration part. So I'll be just playing a video which I have recorded because demonstrate. This is how we'll get to know clearly that how these functionalities happens. Two important things: series connection and max discharge. So this is the battery pack at Decibels Lab, which is connected to our test vehicle. So I'm just explaining. We'll just go through again a glance of what all I explained practically. Current it can take. So this one is a 13S, which means 48 volts. You can see, look at the battery module. This is in 13s in series and 4 in parallel. The cells used are 2.6 Ah and 3.7 volts. So it's around 48 volts, 10 Ah capacity. When you talk about the connection with the BMS with the battery module, you can see there is something called as B negative. There is nothing but battery negative. This directly goes into the negative terminal. So as I was stating, there are two ports, right? Usually, for the even in the battery negative part. Why I was saying just to divide the current. So this is how it looks like. You can again connect another wire and place it over here. Something called as B negative. There is nothing but battery negative. This directly goes into the negative terminal of the battery. Then we have C minus, which is nothing but charge negative, which will also be a discharge negative. Then we have UART and RS485 for communication purpose. Here you can see the communication module is here, which will convert RS485 to directly to the USB, which you can connect to your laptop. Then the main wiring comes here, which connects all the series of the battery module. It starts from negative wire. So I'll just make a glance again. I'll be repeating it. So the thing is, you can see the wire goes like from B minus to the negative part. Then the B0 wire, which is negative, should go again to the same negative terminal, first terminal. Then clearly you can, you can visualize that the series wires are going and getting joined at each series, right? Series 1, 2, 3. The white wires which are going and see joined at the end of the series, right? and then you just collect the C minus and the battery pack main positive part, and you just have the connector at the end. So now you can either use it for discharge or charge, which is known as BC0, which will directly, the black wire, which will directly connect to the negative terminal. So total we have 14 wires, out of which 12 are white, one is negative, one is positive, which is in red color. So first you connect to the negative terminal, then in continuation you connect all the white wires, which you can see here, it has been already connected, and here you can observe this part, right? This is how you connect the series. Then at last you connect the red wire to the positive terminal. So this is how the wiring connection is. Here you can see the thermal. That's how the NTC thermal sensor looks like. Usually have, as I said, no, one or two which will be placed actually inside, right? I just move to the software part now. Yeah, once we'll just look at the battery which is being placed inside the vehicle also. But and we have used 13s 40 amps BMS with it, and this is the wire for the communication. This is the communication block. From here you get a USB connection. So here you could see we have used two wires because the current was on a higher grade above 30 amps, so we used two wires here, and these are 3C cell. Not, it's up to 40 amps, sir. And we have separate wires for charging and discharging, right? This is again a 48-volt system for a low speed vehicle, electric vehicle. You can see in the battery module again, we have one for charging. So we'll go to the software interface part. Just connect the USB connection here through the communication block, then just go to the COM, click on the COM port. Automatically it will select the COM port, which has so COM port and baud rate will be automatic. So if you have any issues while connecting, you can just refresh it, or if you know the port number, you can directly select it, right? And just click on the OK. It's been connected. Press OK. Then you give start. Go to the settings. You press read emperor. It reads whatever. Basically, if you have already given the parameters, if you click on the read after you started, it will read the parameters which you have set, and the data or parameters which has been set for the particular BMS module. You can see reading data is successful. Yeah, one more part. So when you have this indication that read data is successful, then only you will be able to communicate with your BMS. Until then, you won't be able to. Go back to the pack information window. It will give you the current status of the whole battery pack. The module is 13s 40 amps, which you see. You could see that it's fluctuating, right? Here, the voltage is lightly fluctuating once it's connected, which you saw already. So when you talk about the pack information, basically you have number of series connection, so which is 13. So you can see 13 connections here. Then when you can see directly the voltage in series. So this part I already explained to you how the software window looks like. So now we'll look at, I was saying that we set a few configuration and the basic parameters to check how this basically the overcurrent protection or overcurrent via discharging and charging protection, how does it happen, right? So we'll just go directly to that part. Before I go, I'm just showing you the, yeah, could you observe here on the charge and discharge or current protection? I have given an example of 1 amps, that's 1000 milliamps, which is equal to 1 amp. So just to show you that what happens if you have set a limit and how does it cut off, I have given certain example. basic parameter settings. So these are discharge over current, BMS over it can take. You can see on the current, just to show you that how the whole quota. Now first we look at the charging part. Okay, as if if the charger allows over current, I mean charger is providing the current which is above the limit for the battery pack, what happens? We'll just look at it. Happens in the BMS. Now let us see first charging. You can see on the current window there is 4 amps going in, which is above the parameters we have set. You see suddenly there is a so this is what happens. I'll just go back. So we have set 1 amps maximum a charger should provide, right? Let us see first charging. I just switch on. See on the current window there is 4 amps going in. Yeah, so I have used the 4 amps charger. So as soon as the BMS detects that it's a 4 amps coming from the charger, I said there are MOSFETs which will control and which will act like MCB, right? So this is the charge MOSFET which is in green state, which means on. Now it has supposed to be go off or get off, right? Which is above the parameters we have set. Yeah, so you could see it goes into gray color, which is in off state. So, and you'll also get a warning on the window. Suddenly there is a charge MOSFET getting off, which is in gray color. So you could see the charge was in on state. That was due to maximum amount of current. So charger was providing 4 amps, so which was above the amps. You can see here on this window, charge over current protection. Yeah, this is over the red symbol which you saw on the charge OCP, right? That indicates that it's a warning symbol. The BMS has been, I mean, it has cut off because due to so and so reason. So this is your complete warning window where you will be seeing this signal, which will indicate which particular parameter has been gone for the has been attained the protection level, right? So this is how when you just leave your electric vehicles connected to charger overnight, or maybe there is a inrush current passing from your uh, what do I say, switchboards, or from a household power supply, right? So if your BMS is configured properly and it has all the protection level circuit, no matter what, if you charge overnight or if there's a sudden interest current via power supply also, it's role and responsibility to cut off and keep protect the complete, even the charger also protect the battery pack itself, right? So you might have heard a lot of news that vehicles catching fires when connected to charger. So there only we can understand that the BMS configure the BMS which are used in the battery packs are not so in a great condition. So it's not just the temperature or the other surrounding parameters which affect the I mean which results in a battery pack going in hazardous situation or dangerous situation. It all depends on the BMS majorly. So if you make sure your BMS is pretty strong, and then it can take any hazardous situation and keep the battery pack in control. So now we look for the discharge, same. So I've connected to our test vehicle. So it's in discharge mode. Again, for the discharge, just to show an example, I've given maximum 1 amp. The load should withdraw, right? For the battery pack should max it can give is 1 amps. So above that, if the load is asking more of current, then it should cut off. So we'll just look at it. Vehicle is in on. I start giving acceleration. You can look at the window now. Current is in 0. As soon as I give acceleration, it is, yeah, it's showing minus 1.77 amps. Why negative symbol? Negative symbol indicates that it's discharging. If there is no negative symbol, it says charging. So if you are charging, it will be just a number which indicates as a positive sign, right? So 1.77. That's the value above the limit which you have set. So it has to supposed to be cut off the battery pack uh, between the battery pack and the load. Is going up to minus 1.7 and it's getting deactivated. Why is it negative symbol? It is discharging current. You can see the discharge MOSFET will get, yeah. You could just see 1 second. You can see the discharge MOSFET will, yeah, it went off, right? It cut off. And again, the question is, how long will it be in cutoff state? That's what I mentioned, that there was a parameter setting called as delay seconds. The amount of delay seconds you give, based on that, it will try to be in cutoff state. After delay second, it will reactivate and recheck. And if all the things happen, it will continue. Otherwise, it will again deactivate. So again, these delay seconds are all based on the safety factor of safety. So based on that, these values are set. Get off. You can see from red, from green, it's going for gray, and you can see a warning symbol here. Yeah, this is the warning symbol. So just to give an example, your battery vehicle has been set for so and so load condition. So if you are traveling with a more load over the vehicle, so as soon as maybe in that scenarios, you might see this will protect. It will not draw more amount of current. It will not allow the battery pack, the motor to draw more amount of current from the battery pack. Or it can be like if you're going on a hilly climb a region and there's a lot of load on the vehicle which is not able to take the motor, it's not able to take up there. That's where this functionality plays a role. So now we'll just get back to our topic. So you just saw how basically the production level happens, how this functionality performs, right? Now, there was one more important role of the BMS, that was balancing. Now we'll talk about cell balancing part. Uh, why cell balancing is so important, and how does cell balancing happens? We look at it. So on the right hand side, you can see the GIF which states that when cells are under discharge, you're able to see that after certain discharge, they're not in a balanced form. One has still a lot of capacity left in it and compared to other. So this is how typically a normal cell has to perform. Start charging, it goes to 100% and complete capacity is restored. If it's in imbalanced state, that doesn't take place, right? So here's just an example. So this is the voltage of all the three cells when they're in balanced state, right? After certain use, after certain time of using or a certain age of using, cell, you might observe the cell will have a different voltage. That's due to the imbalance created. But look at the remaining SOC. You still can see 4 bars. That's what I was talking about. It will be showing around, let us take an example of 70%, but in truly it won't be able to give you 70% of the capacity. So it would be a kind of like a pseudo value, false value, I would say. That is due to, again, this imbalance which is created. So it is very important to balance the battery, balance the cells to even to know what is the true remaining SOC, and also as a safety part. So again, there is a graph to just show you that what happens when there's imbalance state. So on left hand side graph, LHS, you can see that SOC levels in ideal balanced way. So cell SOC, battery SOC are in a very balanced way. But what happens when cell SOC decreases or it's in an imbalanced way, the overall battery SOC would also get disrupted and you won't be able to get that accurate value. Again, there's a picture to show why balancing is important. How will it affect? So you have two cells here. One is 90H, one is 120H, right? The gray area is a wasted part, I mean, which you won't be able to use it, and white area is in usable part. So there's the remaining, the available battery capacity is 60H, right? Here. So this is an unbalanced state right now. You could see there's a difference between here and there's some balance is not is still in off position. What happens if you start balancing? You can keep on observing that uh, in balanced state it will remove the charge from the excess part and it will make sure that at the end both have the similar I mean, the usable part has been increased. Where you could see the difference from 60 to 90 has decreased and you have flat curve. That's after balance. So you can just observe this part and this part. This was after balancing. This is before balancing. Before balancing, you could see the usable part was very less. When you compare to after balancing from 60H, it has increased to 90H, right? Uh, that's a huge difference. So it's always suggested that the cells are in balanced state. Now, as I was talking so much about the balancing, what are the types of balancing? How do we do it? Before I go to the battery pack level, let's just give a layman term example. Let us consider we have 4 glasses of juices. The quantity of juice present in all the glasses are different. That states that it's an imbalanced state, right? Now, if I give it to you and ask you to balance it, what are the methods you can do? Either you can pour out the one which are in excess. You just pour out the juice outside and try to balance all the glasses. That's one method. There's another method where you can use the excess amount of quantity of juice and make sure that you distribute equally to the neighboring glasses and get it in a balanced state. So these terminologies are called as active and passive balancing. So in active balancing, you distribute the energy to the neighboring cell to get in balanced state. But in passive, you just pour it out or you waste it out in the form of heat by discharging the energy and you balance it. So for example, cell 1, 2, 3, 4 are present. If cell 1 has excess amount of energy with respect to all the 3 cells, there will be shunt resistor, which I showed you on the hardware level. It will draw the amount of current through it and it will just dissipate in the form of heat. So here the disadvantage is you're wasting the energy. You're not able to use that part. But it's not a complicated way of balancing. It's very easy. But when you compare it to active balancing, you're using all bit of energy which is present. There is no wastage of energy. There is no excess heat of the BMS or the battery pack while balancing also. But the disadvantage is here, it's complicated. So this is how, as a battery algorithm engineers, plays a vital role. When you design the BMS, you make sure that all the calculation for what is the right amount of energy has to be distributed among all cells. All these algorithms has to be written and fed into your BMS. Then only the active balancing can take place. Without that, it's very pretty hard. But in passive balancing, it's matter of there are algorithms, but it's just matter of using few hardwares. It will just make sure that it absorbs the excess energy and just pass it out. Right. Thank you. So I hope I have delivered a glance on how BMS and integration and software part. So let me know if any other, if you have any queries, you can just get back to me at streamthedecibels@gmail.com. Um, let me know if you have any queries right